All right, good evening, everyone. We're going to go ahead and get started. My name is Shelby Melto. I'm a meteorologist here at the National Weather Service in Springfield, Missouri. And also joining us today is Mark Birchfield. He is a lead meteorologist here at the office as well. He's going to be acting as our moderator, so if you have any questions coming through, he'll be keeping a lookout for those and answering those questions as they come along. So welcome to the 2022 to 2023 Winter Outlook and Preparedness webinar. Just wanted to say thank you for joining us and taking some time out of your evening to learn about what to expect as we head into this upcoming winter season, and also learn about different ways that you can remain safe in the different products that we issue heading into the winter months. Now, real quick, if you are not familiar with the GoToWebinar interface, there is a tab labeled questions that you'll be able to post any questions that you might have throughout the webinar. And Mark's going to be keeping an eye, like I said, on those throughout the webinar. And at the end of each section, we'll take the time to answer any questions that might come our way. And all attendees are going to be muted throughout the webinar just to prevent that background noise there. So here are the 6 different webinar topics that we'll be discussing throughout this webinar. So first, we're going to be taking a look at the winter of 2022 to 2023 outlook and kind of seeing what we can potentially expect as we head into this upcoming winter season. We'll also be taking a look at the different winter products that the National Weather Service issues so that you can be prepared if we do end up issuing those, and you'll know what actions to take. Then we'll be taking a look at winter science and forecasting. Now, this is a fun topic just because it can kind of show you the background of what goes into our forecasting. And then next, we'll be taking a look at how to accurately measure snow and ice, and also how to send in the reports. You know, the reports that you all send in, we highly value those reports. That's the way for us to know what you all are observing in the area. So it's important to know how to accurately measure those the snow and ice and how to send those in. And then lastly, we'll be taking a look at building a weather-ready nation, you know, becoming weather resilient and just being prepared for when inclement weather may come our way. So first, we're going to start off with a poll, and Mark's going to be sending out that poll here in a second. So for this poll question, we're going to be taking a look at how much snowfall did Springfield, Missouri observe last winter. So from December of 2021 through February of 2022, how much snowfall did we get in Springfield? And your choices are either 10 inches, 14 inches, 16 inches, or 22 inches. So we'll go ahead and give you about 45 seconds to a minute to collect those responses. All right, so it looks like the majority of you answered 16 inches, with 14 inches close behind. So let's take a look and see what the correct answer was. And it looks like 16 inches was correct, so good job, everybody. So we do the measurements here at our office daily during the winter months, and we did end up with about 16 inches of snow last winter. And you're going to see here in a little bit where that amount falls when we look at the annual climatology of the specific snowfall amounts with regards to either being above or below normal. So that leads us into our first topic, which is the winter of 2022 to 2023 outlook. So first, taking a look at the temperature outlooks, and these are put together each year by the Climate Prediction Center. And you can see, looking at the early winter, midwinter, and late winter, if you take a look at the Missouri Ozarks, you really see that there's equal chances for either being above, near, or below normal temperatures. You really don't see that lean either way. And then taking a look at the precipitation outlooks, now it is slightly leaning towards above normal precipitation, especially for the eastern Ozarks, as we head into the early and midwinter. And then you'll notice towards late winter, more of the area is seeing that above normal, leaning towards above normal precipitation there, but really not a huge signal for well above normal precipitation there. So that kind of ties into where we're getting that forecast. You know, one of the big things that we look at is the different types of climate patterns. And the big ones that we always look at are the El Nino and the La Nina patterns. So taking a look at this graph at the right-hand side, we see that for the winter months, you know, we really have the greatest chances for a La Nina winter as we head into the winter season. You see that especially for early and mid-winter, you have this greater than 70% chance of a La Nina winter. And then there's really not that much signal for an El Nino winter. It's really less than 5%. Now, another thing I did want to point out is you'll notice that as we head towards the end of the winter, kind of going into early spring, you'll notice that the chances for the La Nina to continue start to decline, and you'll see that those the neutral conditions, chances for neutral conditions start to increase as we head into the early springtime season there. So what does this exactly mean? Well, taking a look at this, since we have a pretty good bet of a La Nina winter, we can kind of see what a typical La Nina winter pattern looks like. So taking a look at this diagram, you'll see that this blue arrow represents the variable polar jet stream. And you can see that there's an area of wetter conditions across the Ohio Valley and into the mid-Mississippi Valley, and kind of hinting at it towards the Missouri Ozarks and into our area here. So that's really what we were seeing when we saw the precipitation outlooks from the Climate Prediction Center. You saw that slight hint of above normal precipitation. Now, I do want to say it's important to take note of that big blue arrow of that variable polar jet stream. And we're going to see quite a variance with that jet moving either further north or further south. And as that happens, we are going to see our fair share of either the colder shocks of air, as well as our fair share of the warmer shocks of air, depending on the position of that jet stream. So, you know, even though we had the equal chances of above and below normal temperatures for this winter, the position of that jet stream is going to kind of give us either our colder bouts of air or our warmer bouts of air. Now, taking a look here, this is the average annual snowfall by 30-year normals. So you can really see that downward trend of the seasonal snowfall amounts. So taking a look here at from 1991 to 2020, really the annual snowfall normal was less than 14 inches. And then the ongoing trend here from 2001 to 2020 and ongoing, really we're below that 12-inch mark there. So if you remember those 16 inches that we saw last winter, that was above normal, looking at this annual snowfall normal. Now, another thing we did want to point out is, although there is that decreasing trend for seasonal snowfall, we also have a slight increase in the number of light icing events over the past 10 to 15 years. And that's not shown on this chart, but we do have that increase in icing events and that decrease in seasonal snowfall amounts. So kind of summarizing before we move on to our next topic. So as we head into this upcoming winter season, you know, what to expect temperature-wise, there's really no clear-cut long-range signal for either above or below average temperatures. You really have the equal chances throughout the entire winter. But, you know, we could get those warm or cold air outbreaks. Those will likely occur as that jet stream moves in position. but we're going to have shorter lead time. So it's really important to pay close attention to that 1 to 2 week forecast. You know, the Climate Prediction Center does issue 6 to 10 day and 8 to 14 day outlooks. And, you know, those are really important to keep an eye on with that shorter lead time to see if there's a possibility for either a warm or a cold air outbreak. And then taking a look at what we can potentially expect precipitation-wise. You know, there was that weak signal for above average precipitation and snowfall, especially as we head into the late winter months. So again, it's definitely important to pay close attention to that 1 to 2 week forecast, those shorter range forecasts. And another thing, if you remember taking a look at that graph, as we are transitioning from the end of the winter season towards the early spring season, we do have higher chances for that transition to neutral conditions out of La Niña. And typically in the past, we have seen an increase in stormy patterns as we head into the upcoming spring season. Now, I'm not saying that we are expecting more storms this coming spring, but that has been a trend in the past. So it's just something that we're definitely going to have to take a look at as we head closer to the spring season. So that concludes that first topic. So before we head to our second topic, Mark, I'm going to head it on over to you and see if we have any questions.
Thanks, Shelby. So far, we don't have any questions in there. Just a reminder, if you've got your GoToWebinar screen open there's an option kind of on the right-hand side for questions. So feel free to throw those in. If you've got something that we've talked about or haven't yet that you want to ask a question about, throw it in there. But so far, there's no questions.
All right, thank you, Mark. So we will go ahead and start our second topic, which is going to take a look at the different winter products that the National Weather Service can issue. So the first we're going to take a look at the winter weather advisory. And if you look at this image here, the advisory is shaded in those purple colors. Now, when a winter weather advisory is issued, it's definitely important to use caution. You know, we could see those minor disruptions and minor impacts on those roads there. Now, once confidence starts increasing, we might issue a winter storm watch, which shows that warning conditions are possible. So when a winter storm watch is issued, you know, that's the time to really prepare. Make sure that you have all the preparations and all the necessities that you need in case a winter storm warning is issued. And then lastly, we have that winter storm warning, and that's when life-threatening conditions are likely. So that's when you want to take action and make sure that you're staying safe during the winter storm. So we're going to be taking a look deeper into these different products in the next couple slides. So first, taking a look at the winter weather advisory. You know, these are generally issued for anywhere from 2 inches to 5 inches of snow. But that's not necessarily a set criteria. You know, we can issue a winter weather advisory if we get less than that, if we get, say, 1 to 2 inches of snow. You know, it really depends on what impacts are expected. We could be expecting 1 to 2 inches of snow during rush hour. And, you know, when you have all those cars on the roads and we're expecting a couple inches of snow, you know, that could have a huge impact. So that's going to be a big determining factor of if we issue a winter weather advisory or not. Also, holiday travel is a huge deciding factor too. You know, we could get 1 to 2 inches of snow, say a random day in February, but if we get those the couple inches of snow, say during Christmas morning while people are traveling to see their families, you know, that's going to have a higher impact there. So generally, these are issued for 2 to 5 inches of snow, but if we're seeing a couple inches of snow during rush hour or holiday travel, you know, we're going to take those impacts into consideration there. We also issue them for small amounts of either sleet or freezing rain or drizzle as well. So this is why we really don't want you to let your guard down when a winter weather advisory is issued, because as most of you know, it really does not take much freezing rain or drizzle to cause major road impacts, especially when the roads are cold enough to sustain that thin layer of ice there. So definitely want to make sure you are using caution when a winter weather advisory is issued. Now, next, taking a look at the winter storm warning. Now, once we start to gain more confidence that a winter system is going to be a bigger deal than advisory criteria, that's when we're going to then upgrade it to a winter storm warning. Now, these are generally issued for 6 or more inches of snow. However, again, that's not a set criteria. It can be issued for less amounts of snow, especially if there's a combination of sleet and freezing rain expected as well. So definitely want to make sure that you are taking action when a winter storm warning is issued. Now, winter storm warnings, they are a little less common than winter weather advisories. And so this kind of shows the frequency of each product and how often we issue them each year. So this image on the left shows how many annual winter weather advisories we issue for our area. So on average for our area, we issue anywhere from 6 to 8, maybe 6 to 9 winter weather advisories per year. And you'll see those darker colored, darker shades of blue shows which areas are more prone for winter weather advisories to be issued there. And then when you compare that to the right image, you really see how much less common the winter storm warnings are issued. This right image shows the frequency of how often we issue those per year, and really we only issue anywhere from 1 to 2 winter storm warnings per year. And those highest chances are generally across central Missouri for a winter storm warning to be issued. So definitely see that drop off there, but definitely don't want you to take your guard down. You know, anytime we issue either a winter weather advisory or a winter storm warning, definitely it's time to use caution and take action and make sure you're prepared and staying safe. Now, the next product that we issue is a snow squall warning, and we've actually have yet to issue one here at the Weather Service in Springfield, Missouri. So we have not yet issued a snow squall warning yet, but these are issued for short-lived, very heavy bursts of snow, along with strong winds creating blinding visibilities. And so these snow squall events are typically going to be associated with the highway pileups that you might see on the news. You know, we've seen numerous cases across portions of Iowa, even into other central United States locations across the past few years, where a snow squall has created very hazardous driving conditions in a short amount of time. So when one of these is issued, it's definitely a big deal. So we're going to take a look at this video here. This video is from St. Louis back in 2008. So we'll go ahead and take a look here. And you can really see how quickly it went from being generally clear conditions outside. And then when that snow squall came through and visibilities just dropped, and then you saw that ice and snow accumulations on that webcam. So that gives you an idea of how fast things can happen with snow squalls. So, you know, these types of events cause major accidents. So it's a big, big deal if we issue a snow squall warning. So definitely want to make sure that you are prepared and you know what actions to take when we issue this. And the next product is the ice storm warning. And, you know, this is another product that we really haven't had to issue too many times here at Springfield, Missouri. But this is issued when a 1/4 inch of ice accumulation on round objects, such as power lines, is expected. You know, this brings up either flat ice versus radial ice. You know, when we're concerned about that 1/4 inch of ice, we're really concerned about that radial ice and how it builds up on those power lines. But there's also a flat ice component, and we're going to be taking a look at that in a little bit when we take a look at how to measure the different types of ice. And another thing we did want to note with ice storm warnings is that the impacts can really significantly increase as that radial ice approaches 1/2 inch or greater. For example, if you've lived in the Ozarks for a while, you'll remember the 2007 ice storm where much of the region was just blanketed with an inch of ice or greater. So you saw how much of an impact just an inch of ice had. So once we reach that ½ inch or greater threshold, your impacts significantly start increasing. So definitely don't want to ignore when we issue an ice storm warning, because impacts can just be tremendous. And then lastly, we do have a blizzard warning. Now these are issued when we have 35+ mph winds, along with visibilities less than a ¼ mile. Now these are kind of similar to the snow squall warnings, but the only difference is that blizzard warnings last for 3 or more hours. If you remember the snow squall warnings, it just this very quick just bout of winds and lower visibilities. It just came and went. But with the blizzard warning, it lasts for 3+ hours there. So definitely want to remain safe when we do get a blizzard. And then lastly, we do want to keep in mind the winter wind chill products. As we start heading into this upcoming winter season, there are going to be times where we have those dangerous cold temperatures. So when we issue a wind chill advisory, that's showing that cold weather is expected. So typically we issue the wind chill advisory when we're expecting less than or equal to -15-degree wind chill temperatures. So that's where you definitely want to use caution. Make sure that you're dressing warm for the winter. And then when we issue a wind chill warning, dangerous cold is expected. We issue those when we're expecting less than or equal to -25 degrees of wind chill. So definitely want to make sure that you are taking action. Again, making sure you're dressing warm for the winter. If you can, staying inside, avoiding those cold temperatures, making sure you and your families are staying safe this winter. And that brings us to our second poll question. So Mark's going to go ahead and send that out. So for this question, we are asking when the last time the NWS Springfield issued a blizzard warning for any part of our coverage area. So we'll go ahead and give you about 45 seconds to a minute and try to come up with the best answer that you can. All right, looks like 42% of you said A, January 31st through February 1st of 2011. And you would be correct. So good job, everybody. Now this kind of had a couple tricky answers. The answer B, January 12th through 14th of 2007, that's when we had that major ice storm warning. And then C, January 5th of 2014, that's when we had a pretty significant snowfall event, but it was not a blizzard warning. So a couple tricky answers that we threw in there for you, but the majority of you did answer the correct one, and that was January 31st through February 1st of 2011. So that concludes our second topic. So before we continue on to winter science and forecasting, I'll hand it back over to Mark to answer any questions that might have come in.
Thanks, Shelby. So yes, we did get a question that came in from Matt Williams. Thank you, Matt, for the question. I'll kind of read it out here. It says, does the La Nina pattern seem to have greater chances of ice events? And so, Matt, thank you for that question. In general, La Nina typically does not lend itself or really show its cards for any type of winter weather. However, what we can glean from La Nina patterns in the past is that typically early in a winter season, December, maybe through early January, the temperatures can be a little bit above average, which would lend itself to that potential for a little bit of ice due to just the temperatures being warmer. However, kind of looking at our forecast that Shelby showed just a little bit ago, there's not as much of a signal for those warmer temperatures early in the winter so far. So right now, it's not really showing in this La Nina pattern. It's not really showing a greater chance of ice events. Typically, as you go through the rest of the winter in a La Nina pattern, it typically gets a little bit colder and a little bit potentially snowier as the winter goes on. So that was a great question, Matt, and really appreciate it. And if anybody else has any questions, feel free to definitely chat those in there, and we'll get them answered. Thank you.
All right, thank you, Mark. So we're going to go ahead now into our next topic, which is the winter science and forecasting topic. So this is always a fun topic to take a look at because you can kind of see the science behind our forecasts and what leads us to our specific forecasts. So first, we're going to take a look at the winter precipitation types. And the question always comes up, what precipitation type can we expect with this particular system? And if we're honest, this is something that we continue to do research on, not only in the National Weather Service, but also in the meteorological community, because there still remains some uncertainties of how to specifically pin down those forecasts, because all it could take is just half a degree warmer aloft or at the surface to change the specific precipitation type there. But this image here shows what we generally use here at the National Weather Service to kind of forecast what precip type to expect. So if you notice on the far left part of this image, you'll see snow. So you'll notice that the background color of this image is all blue. So the blue color indicates where your temperatures are at or below 32 degrees Fahrenheit or at or below freezing. So as that snow is falling from the cloud and it continues falling down, that vertical column of air, the temperatures in that column of air are remaining at or below 32 degrees Fahrenheit. So that snow is going to continue falling and never melt. So it's going to reach the surface. Now, once we head on over to sleet, sleet begins as either ice crystals or snowflakes. And as it falls from the cloud, it's going to enter into this warm layer. So you'll notice that orange box. And that orange box is showing where our temperatures are above 32 degrees or above freezing. So as those ice crystals or snowflakes are entering into that warm layer, they're going to begin to melt. But you'll notice that that warm layer really isn't that deep. So as the ice crystals and snow begins to melt but continue falling, they are going to now enter into freezing temperatures again. And so that's going to allow these droplets to refreeze and form that sleet, form that ice before reaching the surface. Now, the main difference between sleet and freezing rain, you'll notice, is a much deeper warm layer. So you'll see that snowflakes, as they fall into that warm layer, they're going to completely melt because you have this very deep warm layer. And as they continue to go through that warm layer, once they finally reach temperatures that are at or below freezing, they don't have that much time to refreeze in the form of sleet or ice pellets. So they're going to form super cooled liquid drops. And what's going to happen is once they make contact with the surface, that's when they're going to freeze. So that's how freezing rain forms. And then lastly, on the far right, when we have rain forming, so if snow is falling from the clouds and it enters into this warm layer, you'll notice that the entire vertical column of air is completely above 32 degrees Fahrenheit. So those snowflakes are going to melt. And since the temperatures never reach freezing or go below freezing, the rain is never going to refreeze. So that's when we can see rain. So those are the different ways that we can determine what type of precipitation to expect at the surface. Now that also leads us into the flash freeze potential. Now we could have snow falling on the pavement that is above freezing, and that's going to result in a wet pavement. Now when our temperatures are above freezing and so is the pavement, that's going to result in that wet pavement there. Now if those are very close to freezing, all it's going to take is just a bout of stronger incoming cold air. And that's what the right side of this image is. So when we have that wet pavement, the right-hand side depicts that much colder air coming in behind that frontal passage. So what's going to happen is that as the air temperatures fall rapidly, the pavement temperature is also going to fall, and that's going to create that icy pavement and result in a flash freeze potential for the roadways. And you know, this is kind of a similar process that can happen when you have black ice occurring. When you have that wet pavement either melted by salt or sun, and then you get those cold overnight temperatures, that's going to quickly freeze that onto the pavement, and that can form that black ice. So definitely want to keep in mind the flash freeze potential and also the black ice potential, because that's going to create those hazardous driving conditions there. Next, we're going to take a look at the science of wind chill. So what exactly is wind chill? Well, it's essentially looking at how air is moving the heat away from our bodies. So the left side of this image depicts no wind. So the body is radiating heat and it's creating that layer of warmth between the skin and the cold surroundings. But then once you get those windy conditions on the right-hand side, it starts pushing away that heat. And it really doesn't take much wind. You know, you could have 10, 15, maybe 20 mile per hour winds, and that's going to quickly move the heat away from your bodies and start reducing your body temperatures if you're not dressed properly for the winter cold months. You know, it only takes your body to reach 95 degrees Fahrenheit for hypothermia to begin setting in. So you definitely want to make sure that you're dressing warm for the winter months. And if possible, you know, if we have those dangerous wind chills, trying to stay inside as much as possible there so you don't have to deal with those dangerous cold temperatures. So what do we use for measuring the wind chills? This is the wind chill chart that we use here at the National Weather Service. And you'll notice that the top bar is the actual ambient temperature, and then the left-hand side is the wind speeds, and that ranges from 5 to 60 miles per hour. And as I said, it really does not take much to create those dangerous wind chills. So if you have, for example, a night with lows generally between, say, 20 to 25 degrees Fahrenheit, and you start getting 25 mile per hour wind gusts, you're already starting to get into the single-digit wind chills there. So definitely does not take much to reach those single-digit and dangerous wind chill temperatures. And then the color shaded shows the frostbite times. So as you're getting into the lower temperatures and the higher wind speeds, you're quickly going to reduce the amount of time before frostbite sets in. So you definitely want to make sure that you are staying safe when we get these dangerous wind chills, you know, dressing warmly, staying inside if you can. You don't want to mess around with the cold temperatures because they can be extremely hazardous. Next, we're going to talk about the probabilistic snowfall forecasts. You know, these the probabilistic forecasts provide a range of snowfall possibilities, and we use these in conjunction with our deterministic snowfall graphics. And it's just a better way to communicate the forecast uncertainties during the winter weather events. So these images on the right, these are on our winter page on our website, and I'm going to go ahead and give that link on the next slide. But this image, this big image here shows our expected snowfall amounts, where you can look at a point in different ranges to expect. And obviously in this image, there's no snowfall because this was taken a couple weeks ago. But once we get into a winter event, you know, you're going to see the colors really popping up at the expected snowfall ranges. And then these two images on the right are derived from all of our data and our probabilistic data. So the top image here shows the 1 in 10 chance of higher snowfall. So it shows the high-end amount, shows the more rare amounts that we have the potential of seeing, but it might just be a little bit more rare. And then the bottom image shows our low-end amounts, or our 9 in 10 chance of higher snowfall. So that's a great way to see kind of what we're expecting on the low end and also the high end. And then we can also see, you know, what percent chance of specific amounts of snow do we have. So, you know, percent chance of 1/10 of an inch of snow, or 1, 2, 4 inches of snow. You'll be able to see what percent chance we have of seeing that or higher amounts of snow. And then you can also see on the right-hand side the snowfall totals by location. So you can search the location that you're at and see what the low end and high end snowfall amounts are, as well as what our expected snowfall amount here in our forecasts are. So it's a great tool to have. The link is on this slide. It's just weather.gov/Springfield/winter. It's a great tool to have as we head into this upcoming winter season, so that you can just be prepared and see what type of weather we are going to be expecting as we start getting winter weather events. And, you know, kind of leaving the probabilistic forecasting with this one slide, you know, how to understand probabilistic forecasts. And we really tied into, if you watch football, you know what the goalpost is. Trying to tie it into football in this goalpost, you know, our left goalpost shows our low end amount. So at least this much snow is expected to fall. So that's going to be our 10th percentile. And then the right goalpost shows the high end amount, or the 90th percentile. So we have the potential for that much snow to fall, but that's kind of that high end amount. And then where the football ends up, that's what we believe here at the National Weather Service is the most likely thing to occur. So that's the most likely forecast that we have at the time. So that's how you can kind of visualize how probabilistic forecasting works. It's just picturing that goalpost in football, and where that football ends up is what we believe is the most likely event to occur there. So that concludes the winter science and forecasting section. So we'll go ahead and take another break here and pass it on to Mark to see if we have any questions.
Looks like you covered it well, Shelby. No questions at this time. Just feel free, don't hesitate to ask a question if you need to, but there's no additional questions.
All right, thanks, Mark. So we'll go ahead and now talk about how to accurately measure snow and ice. You know, this continues to be an important part of our agency because we heavily rely on the reports that you send in. So we definitely want to encourage everyone to learn how to properly measure snow and ice and send in those reports when we do get winter weather this upcoming season. We definitely appreciate any reports that you can send in. So first, taking a look at measuring ice. So you'll see the radial ice measurement. That's what we base our warning decisions off of. So in order to accurately measure radial ice, all you have to do is just break off a small twig or branch from a tree that you can see ice has accumulated off of. And you're just going to measure the thickness of the ice on either side of the branch. And once you get those measured, you're then going to take the average, so add them up and then divide by 2. And that's what the ice measurement is going to be. And all measurements should be rounded to the nearest 1/10 of an inch. So that's how you can measure radial ice. But there's also a flat ice component. So when we have flat ice, you know, you can find a flat surface that's been undisturbed from the surrounding environment or from other objects. And you're just going to take that ruler and just measure that ice accumulation. And again, round it to the nearest 1/10. And if we have ice measurements that are below 1/10 of an inch, they're just going to be reported as a trace. So these are great ways to accurately measure ice. But that radial ice component, that is what we base our warning decisions off of. So definitely when you do send in those reports, Showing a ruler is always a great practice to do in your pictures so that we can kind of see how you got that measurement. And then next, measuring snow. So measuring snow can be fun, but it can sometimes be really difficult to measure just because, especially when we get higher winds, that can create snow drifts. And we definitely don't want to measure the snow drifts because that's going to show a higher total than the actual amount that fell. So in order to accurately measure snow, there's 5 different steps that we show. So the first step is to gather the necessary supplies. Really gather a ruler or a yardstick. And we definitely want to encourage you to use some sort of board to collect the snow. That's just a way to get the most accurate measurements. And then you also want to get some sort of flag or something that will show you where you place your board. Because when we get these winter weather events that dump a lot of snow, it might be difficult to find where you put that board. So having some sort of flag to mark where it is will help you when measuring snow. So once you gather the correct supplies, then you're going to plan. So find an open area away from any tall objects, such as your house or a tree, but you want it to be sheltered from the wind. You don't want it to be in the way of any potential snow drifts. So you gathered your supplies and you planned out where you put it. So the next step is to set it up. So set up before the snow begins. So you're going to put your board out and mark it with the flag before any snow falls so that you can get an accurate measurement of the snow amounts that fell from the beginning of the event all the way to the end of the event. And then when you actually measure the snow, make sure you're measuring once daily at the same time so that you can get an accurate 24-hour amount of snow that fell. And again, as we saw with measuring ice, make sure you record your total to the nearest 1/10 of an inch. And then once you record it, make sure to wipe the board after measuring and then placing that board on top of the snow so that you can get an accurate measurement of the snow that fell after you took your last measurement. And then the final step is that once that snow stops, make sure to measure it as soon as possible just to avoid any lower totals due to the snow melting or drifting. You want to get the most accurate snowfall amounts possible. So that is how you accurately measure snow and ice. So that was a quicker topic there. So we're going to take one more second here to pass it on to Mark and see if any questions came through.
Yeah, thanks, Shelby. We did get a really good question in from Brent Hensley. Brent asks, what models do you all use to produce the forecasts, or do you use like a blending of the GFS and the European models? So used to, we would typically, the way forecasting went, we would typically kind of pick and choose maybe a particular model that maybe kind of had the signal or kind of looked like it was going to show the pattern. However, over the last few years, the number of models have increased drastically. So you hear about computer models like the GFS model or the European model. Well, actually, those models within themselves have about 30 to 50 different models that run, different outputs that run within themselves. So we're looking at, and that's just those two. You have the Canadian model, and you have all of these different models that run in different time scales. So there's a few different models that only run maybe for the first 24 hours between now and tomorrow, between now and the next day. So you have maybe 100 or more different models you could potentially look at for a winter weather system. And so that makes it very challenging. And so using a blended approach gives you an idea of where a general consensus is, and then you can kind of take a step back and see how that relates to what has happened in the past during that same event, and see if there needs to be maybe a trend or a skew with that blend. So we do typically use now more of a blended approach. We kind of take all the models, kind of blend them together, and that gives us a good idea where the consensus is. And that's where a lot of the forecasted amounts come from. That's a great question, Brett. Thanks for asking.
All right, thank you, Mark, for answering that. So we're going to go now into our next topic, which is how to send in reports. So you've accurately measured your snow and your ice measurements, and so how do we now send in our reports? So there's several different ways for you to send in reports. You know, you can tag us on social media or call us. You know, our cell phone or our phone numbers is listed there. You can also text us. You can email us at contact.sgf@noaa.gov, or you can tag us on our Twitter and Facebook pages. You know, there's also INWS. You know, that's also going to allow you to submit reports that get sent to us. But there's also this mPING app, and we're going to take a look real quick at what this mPING app is. That allows us to see these reports in real time. So we get these reports that you send in through this app fairly quickly, and it's going to show us the exact location of where you took that report. So this is a great way to get those real-time reports as you are seeing them out in the field, out in the area. So mPING, this is a project that's being conducted with NOAA and the University of Oklahoma. So how you can get this is you can just look in any app store that you might have, whether you have Apple or Android, and all you have to do is just search mPING and that'll show up. So once you open the app, once you download it and open the app, how do you send an mPING report of what you're seeing? So when you open the app, you'll get this image shown up here. So all you're going to do is select report type, and that's going to allow you to select what type of report you want to show that you're seeing. So for this example, since we're heading into the winter months, we selected rain and snow reports. So once you select that, then you're going to be able to submit your report. And once you submit that report, it's going to show that it was successfully submitted. So that's going to show us the exact location that you saw and submitted that report, and that's going to come to us in real time. So we're going to be able to immediately see that report and then be able to issue it as a local storm report, and that's really going to help us see what you guys are observing and really help us in our forecasting and help us see how the event is unfolding. So definitely want to encourage you guys to send in your mPING reports as we start getting these winter weather events, because it definitely helps us here at the office. And you know, another great way to send in reports is joining the CocoRAS program. You know, you can join this as we head into the winter season for reporting snowfall reports, but it's also used throughout the year for measuring rainfall totals, and you can actually buy a rain gauge and take rainfall measurements daily and log them. And those reports are available for anyone to see, including us, which is extremely useful for us to see what you all are observing across the area. So this is a great program to join. It is a volunteer program available for everyone. So if you want to learn more about this program, if you want to join CocoRAS, you can visit cocoras.org, and then visiting that website, that'll help you learn more about the program and help you potentially join so that you can start recording your measurements. So that finishes up our sending reports section. So we'll go ahead and take another quick break, pass it on to Mark, see if any additional questions came in.
Nope, I don't see any questions right now. I do see where a couple did submit some test mPINGs through the mPING app, so really appreciate that. And when you get a chance to check out that mPING app, it's a great way, like Shelby said, to get that information to us in real time.
All right, thank you, Mark. So we're going to head into our last topic of this webinar, and this is where we talk about building a weather-ready nation. You know, building a weather-ready nation, this has really been a big core part of the Weather Service. So what does building a weather-ready nation mean? You know, it really means having that community resilience and preparedness when we do get inclement weather coming our way. Making sure that everyone is weather ready and that they're weather aware, and they know what necessary steps to take if we do have to issue, say, a winter storm warning or a blizzard warning. And, you know, this is something that we're continuing to strive for in building that weather-ready nation. And so you all attending this webinar, this is a great step towards building a weather-ready nation. You're preparing yourselves for this upcoming winter season. So we really appreciate you guys joining us and really learning more and becoming prepared as we head into the winter months. So there's a bunch of different ways that we continue to push our message of preparedness and safety. And one of those ways is through our web page and our graphics. You know, a great tool to have is following our web page at weather.gov/Springfield. And on this web page, you know, we have a lot of great information. We have our hazardous weather outlook, where it shows what type of hazardous weather we are potentially going to expect in both the near future and in the several-day outlook. You can also read our area forecast discussion and see the uncertainties that we might have in our forecast and also what led to our forecasts. And you can also find our weather stories and our graphics at weather.gov/Springfield/weather story. And these graphics are just a great way to see our forecast in graphical form. And a lot of times we do show what type of impacts we're expecting, what type of hazards we're expecting in the locations and timing of certain weather events. So that's a great tool to have and a great way to just remain weather aware. You know, another great tool is our forecast points, and these are also, these can be found at weather.gov/forecast points. And this is a really great and easy way to visualize our forecast here at the Weather Service because it uses the same forecast data as weather.gov. So what it does is it shows weather information in an hourly format for a specific site that you can set up. So if you want to know hourly weather information for your specific location, you can just bookmark your desired location and bookmark your desired settings. And every time you pull up these forecast points, you'll be able to see in an hourly format and also in a graphical format what the weather is going to look like for you in the short term, but also in the weekly term. And you can also view radar and hazards on a map through these forecast points. So this is a really great tool to have as we head into the winter months. A great tool to keep you prepared and keep you updated as to what you can potentially expect as we get into the cold weather and potential winter weather events. And always definitely want to make sure you're following us on social media. You know, our Facebook, Twitter, and YouTube pages. We post our graphics on here. And we also do Facebook Lives and YouTube briefings when we do get those bigger winter storms or winter weather events. So that's just a great way to stay updated on all of our graphics and the potential weather that you can expect. And another great resource is linked down below at weather.gov/safety/winter. And that's a great resource to use because it just shows a bunch of great ways that you can stay safe during the winter months. So it gives a lot of great tips on how to stay safe as we head into the cold season and as we head into potential winter weather events. So definitely want to leverage that and make sure you're following us on social media. And then lastly, there's also this great opportunity to look at what other entities within the Weather Service have to offer. So as you're traveling this winter season, you know, you can see what aviation and marine entities are issuing. So if you're traveling by air, you know, aviationweather.gov is a great resource to use. If you're traveling by sea, you know, weather.gov/marine is another great resource to use. So great opportunity to look at what other entities are using, just adding to your resources so that you can remain prepared and weather aware. And we definitely want to emphasize that it's so important to know before you go. You know, make sure you have a way to receive the latest conditions and the latest weather alerts. So whether that's on your computer, visiting weather.gov, or on your cell phone, make sure that you have some sort of way to receive our alerts and to get the latest conditions so that you know what to expect before you leave your house. So one last poll question before we finish up this webinar. So for this question, Mark's going to send this out. There's really no right or wrong answer. We just want to know what feature is most important to you on a winter weather graphic. Is it the timing, location, confidence, amount, or is there something else that's more important to you? So we're going to take a few seconds here to answer this question. All right, looks like about 50% of you said timing, 25% said confidence, and 17% said the specific amounts. So again, there was no right or wrong answer to this. We just, here at the Weather Service, we really continue to try to better serve everyone in the services and products that we offer. So this definitely helps us know what you all as the public are looking for. So definitely we'll keep this in mind as we head into this upcoming winter season. Try to keep this in mind as we are creating our graphics as we get those winter weather events. So that concludes this webinar. So one thing we did want to leave you with was our information. So this is our contact information on the left-hand side here. It has our website, our phone number, email address, and our social media pages there. So wanted to leave you with that, and also wanted to leave you with a small tidbit on our Weather Ready Nation Ambassador Program. You know, our Ambassador Program, it's a great opportunity to collaborate with us here at the National Weather Service in order to help build that Weather Ready Nation to become weather ready and resilient. So if you want more information on our Ambassador Program, you can either scan that QR code here on this slide, or you can visit weather.gov/WRN/ambassadors. So before we end this webinar, wanted to pass it on to Mark one last time and see if we got any final questions.
No final questions have come in. Just really want to appreciate everybody, and really great job, Shelby, on this great presentation. Got a good feedback there. Thank you for Christopher for thanking us on that presentation, and hope everyone really enjoyed this and was able to get some good information and insights on how to stay safe this winter.
All right, thank you, Mark. And again, thank you everyone for taking time out of your day to watch this webinar. And there is a handout attached to the this webinar here, just showing a bunch of great links of things that we discussed throughout this webinar, ways that you can stay weather aware and weather prepared heading into the winter season. So go ahead and snag that handout there. And again, thank you all for joining, and I hope you have a great rest of your evening.